Today what we're going to be looking at is a law of conservation of energy analogy. Now, we're going to use analogies a lot in my class. An analogy is taking something simple and easy to understand and applying it to a much more complicated kind of situation. We do that with a lot of our science concepts in class, and the concept we're going to apply that to this time is the law of conservation of energy. Now, the law of conservation of energy is something you probably have heard of. This is a law that governs all natural phenomena of energy. There's no known exception to this law, and the strange fact is if we calculate energy before and then allow it to undergo a change, and we calculate it again, we always get the same number. So here's my analogy. We'll use Stewie from Family Guy. So we're going to imagine Stewie has some blocks which are absolutely indestructible. Those blocks cannot be divided into pieces. Each block is identical as all the others, and he has 100 of these blocks. Now, this is what a Stewie block looks like, and we're going to say that each Stewie block, I got 100 of those things. Now, to understand the analogy, you have to understand what the blocks represent, because that is the foundation of the analogy. So you have several choices. Pick one you think is correct. Does the block represent toy, energy, system, or energy transformation? The block represents energy. Now, when we think about energy, here's where our analogy falls apart. Light energy is not a block. I can't grab it, I can't put it in my hand. However, in our analogy, that's what we're going to be using to simulate our blocks. Now each day, Stewie's mom comes in, she puts 100 blocks into his bedroom every single day. Okay, so every day he starts with 100 blocks into his bedroom. Now, in our analogy, we're also going to say what Stewie's bedroom represents. Now, we know that the blocks represent energy. So what do you think the bedroom would represent? A, B, C, or D? The blocks represent the system. Now remember what the system is. The system is what we want to pay attention to. We want to focus on what's happening within that system. Now, system again is the area we want to look at. So for example, we're going to call Stewie's bedroom a closed system. A closed system. And what we're going to look at is how the energy may move around within that system. Now one day Lois comes in at the end of the day and she counts only 99 blocks. Well, she knows she started the day with 100. So sure enough, she looked and looked and looked. Stewie had hidden one of his blocks under the rug. Now, in this idea, we are now back to 100. She had to look a little harder to find that block of energy. Sometimes it's not just out in the open, and you've got to hunt for it, but sure enough, she's back to 100. Another day, Lois comes in at the end of the day, and she counts only 99 blocks. Again, she knows she started the day with 100. She looks around, can't find it. There happens to be a bathtub in Stewie's bedroom, and sure enough, she noticed that the water level on the tub was a little bit high. And there it was. She's now back to 100. Now the idea here is that sometimes we have to use indirect measures to indicate when there is energy. For example, if I'm detecting thermal energy, I may choose to use a thermometer. If I'm detecting light energy or electromagnetic energy, I may have to use alternate measurements to actually detect it. Once again, we're back to 100. Now another thing that can happen with energy is it can exit a system and it could go outside. Well, we don't call that a closed system anymore. In that situation, it would be like exiting the window, and we call it an open system. So that is a different kind of system than the first example. So one day Lois comes in at the end of the day, she counts 98 blocks. She looks under the rug, she looks under the tub. She cannot find them anywhere at all. She noticed that the window was open and found 2 blocks sitting underneath the window. Silly Stewie threw 2 blocks out of his bedroom. So it had exited the system. She brought him back in, and now she's back to 100. Once again, she's always able to track where her energy is. Energy could also enter from the system from the outside. We still call that an open system, just like an open window. So one day Lois comes in at the end of the day and she counts 102 blocks. She realized that Brian had come to visit. He had brought 2 extra blocks with him. She sends him home and she sends his blocks with him. So then she's back to 100. Energy can't magically appear. It's got to come from somewhere. Once again, sending it back out, she's back to her 100 blocks that she started with. Now, if we have a closed system, then look at the choices. What could happen? A, B, C, or D? There is no D. It's C. Total energy remains the same. If the number of blocks decreases in the bedroom, and she's counted everywhere, what's the choice? A, B, C, B. Energy has exited. And sometimes it could exit lots of different ways. In our analogy, he threw the blocks out the door. However, we could also have sound energy. We could have vibrations through the table. Energy can exit systems quite easily. If the energy leaves, what kind of system is that? Open system, out the window. If the number of blocks in the bedroom increases, then what happens? Choice A, energy has entered the system. And once again, it has to come from somewhere. Now, what we are going to be looking at is Law of Conservation of Energy reading page. I want you to go pick up, and you can start until it's time to swap to the next rotation group.